ஸ்டார்ட் பண்ணலாம் சார். ஸ்ரீதர் சார் கொஞ்சம் மியூட் பண்ணிக்கங்க சார். பேக்ரவுண்டுக்கு வாய்ஸ் இருக்கு சார்.
சார் உங்க
Ravi sir, you can start, sir.
Yes sir, yes sir.
Good morning to one and all. I welcome you all for today's event. The design, it's part of the design series. It's the first episode of the design series, and today we are going to be having a technical talk on how to size and design ducts. And speaker for the day is Dr. V. Balasubramani. Dr. V. Balasubramani is working as an assistant professor at the Department of Mechanical Engineering in Tyagaraja College of Engineering, Madurai. He has more than 20 years of teaching experience. He has published 10 international journals, presented 18 international conferences, organized 4 workshops, and has delivered 25 guest lectures. He has contributed to the consultancy works for IFB Industries Limited, Goa, Samir, Chennai Engineering and Business Analytics, India Private Limited, Bangalore, Tyagaraja Telecom Solutions Limited, Madurai, ATC Tires Limited, Tirunelveli, and SI Air Springs Private Limited, Madurai. He is also an active member for ISRE Madurai chapter. And I hope you all will be having a very wonderful session today. And it's over to you, sir, for today's event.
Thank you for a nice introduction. So first I thank Tyagaraja College of Engineering management, the principal, and the head of the Department of Mechanical Engineering for permitting me to deliver a lecture in ISRE. So I also thank the ISRE member Dr. K. Sridhar, President, and Mr. C. Savridas Franklin, President-elect, and Mr. K. Gaja Moedin, Secretary of ISRE Madurai chapter, and Mr. N. Balachandran, Treasurer of ISRE Madurai chapter. And I also thank Raji Krishna, Program Chair of ISRE Madurai chapter. So today I am going to give a idea about ducts used in air conditioning. And so my presentation, the topic says how to size and design a duct. Is it visible to all, the PowerPoint presentation?
Yes, sir, it's visible.
Yes, sir, it is visible.
Thank you, thank you. So the given topic is how to size and design a ducts. So everyone knows about duct and some methods as well as many parameters related to ducts. Anyhow, so my presentation is based on 2 major things. One is HVAC as well as ASRE fundamentals. So my presentation, I'm having my outline of presentation. First one of ducts. What is a duct and what are the classification of air conditioning, and then design principles involved in duct, and then types of duct, obviously, then materials for duct, and then duct sizing methods. There are 4 methods are available. We will discuss 3 methods like equal friction method, constant velocity method, and static regain method. So using some the case study. So this is my presentation outline. So first I have to start with the fundamental 5 or 6 slides. Then I will enter into the design principle. Then I will enter into the main criteria. So most of the people were aware of the purpose of duct. So students are also there. So they must know what is the duct. Ducts are passages used in heating, ventilation, and air conditioning to deliver and so remove air. So we have the ducts needed airflow, including a supply air, returner, and exhaust air and air conditioning system. So we have to use a duct. So commonly the ducts are deliver ventilation as air as a part of the supply air, and then air ducts are the one of the method of ensuring acceptable indoor air quality as well as thermal comfort. So major purpose of the duct is to deliver as well as remove air. And then the types of air conditioning, there are 2 types of air conditioning. Everyone well aware of it, ductless as well as ducted. So in duct air conditioning, we have to use a air handling unit. From the air handling unit through the ducts, so we are supplying the required air to the room size. But in ductless air conditioning, so we are using outdoor unit. The particular unit supply air to the particular room only. So the types of ductless air conditioning system, so everyone aware of it, split window, portable and cassette type air conditioners. And the ducted air conditioning system, the split central air conditioning, the packaged central air conditioners. So where there are two types of ducts are using, one is a flexible, another one is a the rigid duct. So in a rigid ducts, mostly the metal and the fiberglasses are dominating in the materials for the duct. So what is the requirement of the duct? So now we know what is the duct, what is the requirement. So requirement is the first one is a very important. So it must convey a specific rates of airflow to the prescribed location. That's a very the important requirement of the duct. Specified airflow. That purpose only we have to design and size the duct. And then our duct material and all the things, the system, the duct system should be economical in combined initial cost, fan operating cost, and the cost of building space, all the things. So as a system, it should be economical. It must not transist or generate noise. That's very important. Otherwise, we have to use a dampener also. A well-designed ductwork should deliver a maximum interior comfort at the lowest operating cost, while also preserving a indoor air quality. That's a very the need. The maximum interior comfort is our requirement. That purpose only we have to design a suitable duct. And then ducts are not well designed. I think so. You are aware of it. Discomfort, high energy, bad air quality, and then increase the noise level. And then you take about in this diagram, it clearly indicates the amount of cost for a total fully air conditioning system. The duct work contains 15% of cost. So you know the importance of the duct. So we have to give the more importance to the duct work. Okay, next I just move to the design principles. There is the fundamentals. Some of the parameters I have to use repeatedly in 3 methods. So those watts are given for your understanding. CFM is nothing but the measurement of airflow. That's a cubic meter per minute. That's a CFM. And then FEM is feet per minute. That's a velocity as well as a square feet. So CFM is nothing but it's a product of FEM and area. That's a very the most fundamental. Then pressure. There are 3 pressures are involved in the duct. The based on the first one, the last method, the static regain method. The static regain method is nothing but they have to regaining the static pressure inside the duct. That's the method. The method we are trying to maintain the static pressure between the input as well as the output, the first branch as well as the second branch. So the static pressure is very important. It is the air pressure in the duct. Velocity pressure is nothing but it is a pressure generated by the velocity. Total pressure is to find out the velocity pressure. So static pressure and velocity pressure, total pressure. Total pressure is equal to static pressure plus velocity pressure. Then airflow. So obviously, how is the airflow? So because you know the second law of thermodynamics as well as the conservation of mass, conservation of energy, and the conservation of energy. From the air is moving from. So obviously, the pressure difference between the point, there is high pressure to the lower the pressure. And then total pressure is algebraic sum of velocity pressure and static pressure. I have already told. And then airflow characteristics of the duct. How the 3 pressures are measured. So the static pressure which are measured parallel to the airflow, as well as total pressure which also measured the parallel to the airflow, and velocity pressure which are measured the perpendicular to the airflow. So are perpendicular to the static pressure. So mostly static pressures are measured at the circumference of the duct. There is a static pressure, and the total pressure is measured at the inside of the duct. And then the velocity pressure is you know. So now initially I have told the total pressure is used to find out the velocity pressure. If you combine both the things, I think you may calculate the velocity pressure inside the duct. This is the airflow characteristics of the duct. And then how the magnitude of static and velocity pressures are dependent. So if constant cross-section areas are used, the total and static pressures may be the equal. And then if you are using a diverging section, that's I have already told. If you are increasing in a duct size, the velocity pressure decreases and total pressure decreases and the static pressure increases. So aim is velocity decreases, the static pressures may increase. So there is a static regain. So this concept is adopted in the static regain method. Then converging section, converging we are reducing pressure and we are reducing the static pressure. Sometimes this concept may be also used in a static regain. So our aim is the static pressure is always greater than the system pressure. That's the principle of static regain method. So that purpose, I think we are using a converging section also. So other one, static pressure for a fan selection. Using a static pressure, we may select the suitable fan, and then velocity pressure for measuring the CFM, so cubic feet per minute. And then a duct component. There are many components are there. We have already discussed in the first slide. Supply air ductwork. So conditioned air from the air handling unit to the conditioned area. Then return air ductwork. So removes air from the conditioned building spaces and returns the air to the air handling unit. Now, some of the applications we are removing the air. The best example is it's a kitchen, bathroom, and we are removing the air. And then fresh air ductwork supplies outdoor air to the air handling unit. And the exhaust air ductwork. The exhaust air ductwork is used in toilets, kitchens, and laboratories. It carries and discharges air to the outdoors and the mixed air. So we may use any two types of the things. And then this is a air conditioning schematic drawing. So mostly many of you are aware of it. This is a duct components. There are many components are there. The four components are very important. There is a main duct, and then a trunk duct, takeoff, as well as a diffuser. So these are the four important components. All other components are required in the duct design, but I am not concentrating in all because of a time limitation. Main components is the main trunk. The main trunk is the main part of the supply and the return duct system that goes directly from the air handling unit, which is directly contacted to the air handling unit. So trunk duct is equal to the duct is split into more than one duct is called a trunk, just like a tree. So these are mostly these ducts are designed from the main trunk only. The ducts that are the end of the trunk and terminate in a register are called the branches. Takeoff. So takeoff is the branch ducts are fastened to the main truck by takeoff fittings. So takeoff is nothing but this is the joint. The takeoff encourages the air moving the duct to enter the takeoff to the branch duct. So that's a takeoff design. And takeoff modeling is it is also having a lot of ASRE rules and ASRE design principles. And air terminal devices. So air terminals are a supply air outlet as well as a returner. For supply, we are using diffusers are common. Sometimes we may use a diffuser in return air purpose also. The register is also equipped with a volume control damper for a air terminal device. A grill is a component is a without a damper. If you are using a with damper, it is called a register. And then duct materials. If you take about duct material, these are the popular metallic materials. So metallic duct, galvanized steel, and aluminum, stainless steel, and carbon steel, as well as in a copper. So if you take a copper, it is mainly used for a chemical exhaust as well as a ornamental ductwork. So mostly in our system, there is a residential and other things. So the aluminum ducts are placing the vital role in a duct material. Aluminum is the most popular material. And then a non-metallic duct. So non-metallic duct is also nowadays becomes more popular in most of the application because of the reason. So mainly it is used for chemical exhaust, scrubbers, and underground duct system. So these are the advantages why we are choosing FRP, fiber reinforced plastic, the composites. So advantages are resistance to corrosion. That's the meaning. Then self insulation because of material composition. Then excellent sound attenuation. There is an excellent sound absorber, high quality sealing. So limiting characteristic is a cost. So the comparing to aluminum, its a cost is very the high. And then there is a manufacturing of FRP is also somewhat difficult. And then PVC, there is a plastic. It is also used for exhaust systems for chemical fumes and underground ducts is also. Advantages similar to the previous: resistance to corrosion, lightweight. Resistance to corrosion and lightweight and ease of modification. But it is does not absorb the sound. So limiting characteristic, it is also having the high cost and the fabrication, then thermal shock and weight. And then fabric. So fabric is the textile duct. It is usually made of a spherical preamble polyester material and is normally used where air distribution is essential. So due to the nature of the air distribution, textile ducts are not usually concealed while within the false ceilings. This is not we are not using because it is a consumes air. It is a continuously discharging air. Then flux duct. The flux duct consists of a duct inner liner supported on the inside of the helix-wide coil, covered by a blanket insulation. So it may be used the additional material. It provides the insulation also. So these are the some of the advantages as well as the limitations of the ducts, metallic as well as the non-metallic. And then classification of duct. So obvious, based on velocity, 3 types: low, medium, and high. Low means up to 2000 FEM, feet per minute. Medium means 2000 to 2500. High velocity means 2500 FEM. Greater than 2500 FEM is known as the duct classification based on velocity. Similarly, pressure, low, medium, as well as a high. So what's called a low pressure? That's the pressure is a 3 inches water column. The pressure is converted into water column, 3 inches water column. But medium pressure is equal to 3 to 6 inches water column, and high pressure is equal to 6 to 10 inches of water column. And then the corresponding the velocity is also given. For a low, 1500. For a medium, 2500, as well as for a high, there is a 4000 the FEM. So what is the best engineering practices? So now we have some of the idea about different types of duct, and then duct components, and then duct material and other things. So medium pressure, use of medium pressure classification for a primary air duct, the fan connection, risers, and main distribution. Low pressure classification for a secondary air duct. There is a branches from the main terminal boxes and the distribution. In the first diagram I shown the components. There are main ducts are there, and the other things are maybe used as a low pressure. And then a duct pressure classification influences the duct strength, deflection, and air leakages. Duct velocity influences a noise vibration. So we may use a dampener. So depends upon the duct velocity, we may use a dampener, noise, vibration, friction losses, as well as the fan power. Okay, so up to now I just give the important as well as the basics of duct, and then now I will ask some questions so related to my lecture. So you try to answer my questions. I will ask only 5 questions. The percentage of cost involved in a duct design according to HVAC. So what is the percentage? Anyone?
15, sir.
15. Very good. Very good. Very good.
15, sir.
Exactly correct. 15 is exactly correct. Okay, next. 15 is correct. The second is a static pressure is measured in to the direction of the airflow.
Perpendicular of airflow.
Perpendicular
Airflow, sir. Airflow.
Direction of airflow. The static pressure is measured parallel or perpendicular. Only 2 directions are there. ரெண்டு தான். So ஏற்கனவே ஒருத்தர் சொல்லிட்டாரு perpendicular ன்ட்டு கிடையாது, parallel to the direction of airflow. So எது வந்து பண்றோம்னா velocity, the velocity pressure is measured perpendicular to the air direction. Total pressure, any idea? Total pressure is measured in, it is also similar to the yes, no, total pressure is measured which direction of the airflow? Parallel to the direction of the airflow. It is also similar to the previous. Okay, next, the maximum velocity value used in a high velocity system. High velocity system, there are the velocity in terms of FEM, feet per second. What is the value? Enna value irukkalam?
4,000.
4,000.
Above 2,500.
Exactly correct. 4,000 above, greater than 2,500. Anything, but we have to limit it to 4,000. Exactly correct. So greater than 2,500 FEM is the correct answer. And so one more question and last question. The branch ducts are fastened to the main trunk or main duct by means of ரெண்டுமே எதுல ஜாயின் பண்ணுவோம்?
Trunk off.
Trunk off la take off.
Take off.
Okay, correct. No problem. Okay, இந்த வேர்டிங்ஸ்லாம் நமக்கு தெரிஞ்சதுன்னா பின்னாடி நமக்கு ஈஸியா இருக்குங்கிறது தான் அந்த பர்பஸ். ரைட். Okay, next I just move to the duct shape. This is a very important in design. Ducts are commonly used for carrying air, are available in the shape of circular, square, and oval, or rectangular duct, round duct, and oval duct. Then first we have to talk about the round duct. So the round duct, there is a duct type. The round duct is the most efficient. It offers the least resistant, and it is the most efficient in conveying a moving air in a round duct because it has the greatest cross-sectional area and minimum contact surfaces. So because it is a continuous curved surfaces அப்படி இருக்கிறதுனால இது வந்து என்ன பண்ணுதுன்னா ஸோ நமக்கு லீஸ்ட் ரெசிஸ்டன்ஸை கொடுக்குது. ஏன்னா ரெசிஸ்டன்ஸே இருக்காது, போய் எங்கிட்ட போய் இடிச்சா தானே. இப்போ ரெக்டாங்குலர்ல போய் இடிக்கும், அந்த ஷார்ப் எட்ஜஸ் இருக்கும், அதனால நமக்கு ரெசிஸ்டன்ஸ் வந்து ஜாஸ்தியா இருக்கலாம். பட் ரவுண்ட் டக்ல அது இருக்கவே இருக்காது. அதனால என்ன ஆகுதுன்னா the least resistance. It uses a less material compared to the square and rectangular. நான் ஏற்கனவே ஒரு சின்ன எக்ஸாம்பிள் கொடுத்துருக்கேன். An 18-inch diameter duct has a cross sectional area of 254.5. So 5/4 d square ல போட்டோம்னா 254.5 square inch and perimeter is equal to 45.72 inch. So volume is 11,635 the cubic inch for 18-inch diameter. For similar, for this kind of square area, if I'm using a rectangular duct, 26 inches into 11 inches rectangular duct, it has a cross section area of 286 and the perimeter of 74 inch. You please note down the perimeter is a 74 inch and volume is a 21,164 cubic inches. So the rectangular duct has a 32% more metal comparing to the circular duct. 32% more metal is required and it would cost proportional more, as well as insulation and support and labor also, all the things are the increasing. So that's the major advantages of the duct. So it occupies a minimum material and it offers a least resistance, as well as it has advantages of lower pressure drop because its resistance is a low, the pressure drop is a low and requiring a less fan horsepower to move the air. Consequently, for a smaller equipment, it has a less surface and requires a less insulation when externally wrapped. So they are available in a longer length also. Another very important is the acoustic performance. There is the noise. The acoustic performance of a round and oval ducts is superior because of their curved nature. It allows a less breakout noise. The low frequency sound is well contained in a round duct. So they help promote a healthier indoor environment, less surface area, no corners and better airflow, reduce the chances of dirt and grime accumulating inside the duct, therefore becoming a breeding ground of the bacterial growth. So advantages is because of a lower pressure drop, the better acoustic performance. So if it is a better acoustic performance, there is no chances of dirt and other things. So these are the advantages. But limitations is not a limitation. Nothing. The only one is a limitation. The fabrication as well as fitted with the ceiling. So we cannot easily fit it into the ceiling. So we have to design the suitable fixtures and other things. So those things are very difficult, and joining of the branch as well as the main. So it creates a lot things in a circular duct. In a rectangular duct, it's a square or rectangular, both are comes under one category, rectangular duct. So it ducts fit better to the building construction. So nowadays, most of the engineers are preferring because of the fitting. So that cost is very high. Other things are okay, but that cost is very high. So we prefer a rectangular ducts for because it's a good fit to the construction. Whatever it may be, it consumes more metal and other things, but the fitting is very, very easy. So that purpose only rectangular ducts are preferred over than circular duct nowadays. They fit above the ceilings into the wall, above ceilings or into the walls, and they are much easier to install between the anything, so joists and stud, whatever it is, any critical area we can easily insert. When rectangular ducts must be used due to the space limitation, the keep width to height ratio, it should be very, very low. The aspect ratio is nothing but it is a ratio between the longer dimension to the smaller dimension. And then limitation, higher pressure drop, because higher resistance, higher pressure drop, use more metal, joint length is limited to the seat width, the joints are difficult to seal, and then high aspect ratio can transist the excessive noise. So what is called aspect ratio? So aspect ratio is nothing but I have already told it is the ratio of higher dimension to the least dimension. அதாவது அதிகமான டைமென்ஷன் வித் இருக்கும். அதாவது நமக்கு ரெக்டாங்குலர்ல ரெண்டு டைமென்ஷன் இருக்கும். அது எது வித் எது ஹைட்னு சொல்ல தேவையில்லை. லார்ஜர் டைமென்ஷன் அஸ் வெல் அஸ் ஸ்மாலர் டைமென்ஷன் ரெண்டுக்குள்ள ரேஷியோ எப்படி இருக்கணும்? ஆஸ்பெக்ட் ரேஷியோ அது 1ல இருந்து 4 வரைக்கும் இருக்கணும். ஸோ இது யார் ரெக்கமெண்ட் பண்றாங்கன்னா, விச் இஸ் ரெக்கமெண்டட் பை ஸ்மாக்னா, சீட் மெட்டல் அண்ட் ஏர் கண்டிஷனிங் கான்ட்ராக்டர்ஸ் நேஷனல் அசோசியேஷன். இது ஒரு அசோசியேஷன் விச் இஸ் ஃபார்ம்டு பை த பீப்புள் ஒர்க்கிங் இன் த டக்ட் ஏரியா. அவங்க தான் இந்த ஆஸ்பெக்ட் ரேஷியோவை டிசைன் பண்ணி ஆஸ்பெக்ட் ரேஷியோ சுட் பி அவைலபிள் வித் இன் த ரேஞ்ச் ஆஃப் 1 to 4. ஸோ எப்படி இருக்கணும் அப்படின்னா 1ல இருந்து 4க்குள்ள இருக்கணும். இஃப் இட் இஸ் இன்க்ரீசஸ் இட் ஆக்குபைஸ் அ மோர் ஸ்பேஸ். If it is increases, it occupies a more space. For example, பாத்தீங்கன்னா இது வந்து ஒரு ரெக்டாங்குலர் டக்ட். இப்ப நான் இது வரையறேன். இது வந்து 8 x 2. அப்ப 8 2 பாத்தீங்கன்னா 16. அதுக்கு பதிலா நான் ஒரு ஸ்கொயர் டக்ட் போடுறேன். ஸ்கொயர் டக்ட் போட்டோம்னு வச்சுக்கோங்க, 4 x 4 16. ரெண்டுக்கும் ஒரே கிராஸ் செக்ஷன் ஏரியா தான், அதனால ஒரே வெலாசிட்டி ஒரே சிஎஃப்எம் தான் வரும். பட் இதுல ஆஸ்பெக்ட் ரேஷியோ 8/2 4. இதுல ஆஸ்பெக்ட் ரேஷியோ 4/4 1. ஸோ இதோட மெட்டீரியல் பார்த்தீங்கன்னா 8 + 2 8 + 2 16 + 16 32 இன்ச்சு எவ்வளோ வரும். ஆனால் இது அப்படி கிடையாது. சாரி 20 இன்ச்சஸ் வரும் பெரிமீட்டர். இது அப்படி கிடையாது. 4 4 8 8 16. ஸோ அப்போ மெட்டீரியல் பாருங்க நமக்கு எவ்வளோ ஜாஸ்தியா இருக்கு, இது எவ்வளோ கம்மியாகுது. பட் எல்லாத்துலயுமே நம்ம ஸ்கொயர் யூஸ் பண்ண முடியாது. பிகாஸ் ஆஃப் மேனுஃபேக்சரிங் கன்சிடரேஷன், அவைலபிள் மெட்டீரியல் அதெல்லாம் நம்ம பார்க்கணும். ஒன்னு எல்லாமே ஸ்கொயரா யூஸ் பண்ணிடலாம். 4.1 4.2 4.3ன்னு வச்சுக்கோங்க. ஸோ அதுவும் நமக்கு கஷ்டம். மேனுஃபேக்சரிங்கையும் நம்ம பார்க்கணும். நம்ம பக்காவா டிசைன் பண்ணி கொடுத்துட்டு அவர் ப்ரொடக்ஷன் பண்ண முடியலன்னு நம்மள தான் திட்டுவாரு. ஸோ டிசைன் இன்ஜினியர் மஸ்ட் கன்சிடர் டிஃபிகல்டிஸ் ஆஃப் ஆல் த பீப்புள். எல்லாரோட பீப்புளோட டிஃபிகல்டிஸை கன்சிடர் பண்ணணும். அதனால ஸ்கொயர் டக்ட் மேபி used in some occasions, but mostly the rectangular ducts are the used because of manufacturing capability. And then the oval duct, the flat oval ducts have a smaller height requirement. இதுல வந்து எப்பவுமே width ரொம்ப கம்மியா இருக்கும். that round ducts and retain most of the advantages எல்லாமே இருக்கும். but oval இதுல என்ன சார் difficulty அப்படின்னு பாத்தீங்கன்னா, handling and shipping a larger size. இந்த difficulty பண்ணது மேல லோட் போட்டா அது அமிங்கிரும். So tendency of these ducts to become a more round under pressure. அதிகமா பிரஷர் ஆச்சுன்னா என்ன ஆகும், இது ஓவலா இருக்கிறது சர்க்குலரா மாறதுக்கு வாய்ப்பு இருக்கு. அப்ப நம்ம டிசைன் ஒண்ணுல பண்ணிருப்போம், அது ஒரு பேச்சுன்னு வச்சுக்கோங்க. ஸோ நமக்கு அந்த கம்ஃபர்ட் லெவல் இருக்காது. இன் லார்ஜ் ஆஸ்பெக்ட் ரேஷியோ டிஃபிகல்டிஸ் ஆஃப் அசம்பிளி. ஸோ இதான் வந்து டிஃபிகல்டிஸ் ஆஃப் ஓவல். ஸோ நெக்ஸ்ட் பாத்தீங்கன்னா we will move to the equivalent diameter. So இது எதுக்கு அப்படின்னா, இது வந்து ஆஸ்ட்ரேயோட ஈக்குவேஷன், ஆஸ்ட்ரேயோட ஃபண்டமெண்டல் ஹேண்ட் புக்ல இருந்து எடுத்திருக்கிற ஃபார்முலா. So equivalent diameter அப்படி பாத்தீங்கன்னா is the diameter of the circular duct that will give the same pressure drop at the same airflow as the rectangular duct. அதாவது சர்க்குலர் டக்ட்ல என்ன டயமீட்டர் இருக்கோ அதை அப்படியே வந்து நம்ம ரெக்டாங்குலரா கன்வெர்ட் பண்றோம் வித் சேம் பிரஷர் ட்ராப் அண்ட் சேம் ஏர் ஃப்ளோனா இதுதான் ஃபார்முலா. அப்ப ஈக்குவலன்ட் diameter may be calculated by this equation. So here you can see the one equation, the DEQ is equal to 1.3 into AB into 0.625 plus A plus B into 0.250. You don't worry about how these equations arrived. These equations are available in ASTRE fundamental handbook. So this is a flat oval duct. The DEQ is equal to 1.5 into A power 0.625 divided by P into 0.250. அங்க A அப்படிங்கிறது இங்க தான் A. இந்த AB அப்படிங்கிறது இங்க A அப்படிங்கிறது என்னன்னா length of the major axis, B is equal to length of the minor axis. அதே தான் இங்கேயும் நம்ம இதுல ஓவல் டக்ட்லயும். பட் இந்த flat oval ducts the D equivalent is equal to A is equal to the cross section area. The cross section area of oval duct, the P is equal to perimeter of the oval duct. So now we may find out the equivalent diameter. So next one is equivalent the cross sectional approach. We will discuss one problem. So we have just give one the simple problem to convey the duct sizing as well as the duct designing method. So அது போறதுக்கு முன்னாடி ஒரு சிம்பிளா ஒரு ப்ராப்ளம் இருக்கலாமேன்னு பார்த்தோம். கன்சிடர் ஆன ஏர் ஃப்ளோ ரேட் ஆஃப் 7500 CFM and compare with the 30 inches diameter double இது போட்டால் அது வந்து இன்ச்சு, சிங்கிள் போட்டால் அது ஃபீட்டு. ஸோ 30 inch diameter round duct to equivalent rectangular and oval duct மாற்றணும். ஸோ எப்படி மாற்றலாம்னா, ஃபார் அ கிவன் ரவுண்ட் டயமீட்டர் த டைமென்ஷன்ஸ் ஆஃப் த ரெக்டாங்குலர் அண்ட் ஃபிளாட் ஓவல் டக்ட் மே பி கால்குலேட்டட் பை அ ட்ரையலர் அண்ட் எரர் மெத்தட். ஒன்றை மட்டும் நான் கான்ஸ்டன்டாக வச்சுக்கிட்டு அந்த ஈக்குவேஷனில் போட்டால் எனக்கு வந்துடும். ஸோ அது நமக்கு தேவையில்லை, போட்டால் வந்துடும். இல்லைன்னா நமக்கு நிறைய தேர் ஆர் கன்வெர்ட்டிங் சார்ட்லாம் இருக்குது ஃபண்டமெண்டல்ஸில், நம்ம அதெல்லாம் பார்ப்போம். ஸோ இதுல இருந்து கூட எடுக்கலாம். ஐ திங்க் இருக்குல்ல த ஈக்குவலண்ட் ரெக்டாங்குலர் டக்ட் டைமென்ஷன். ஸோ இப்போ இதில் வந்து பார்த்தீங்கன்னா 30 இந்த இருக்கு 30. நான் என்ன பண்ணியிருக்கேன் 16 வச்சிருக்கேன். இந்த இருக்கு 30, இங்கே பாருங்க 16. நான் ஒரு சைடு 16 அசியூம் பண்ணிட்டேன், அதர் சைடும் இப்படி கொடுத்துருக்காங்க. அப்போ 30 அப்படின்னா அப்படியே நீங்கள் இங்கேருந்து 30லேருந்து ஒரே ஒரு ஹரிசாண்டல் லைன் போடணும். அது வந்து பார்த்தீங்கன்னா 51 முட்டும். 16லேருந்து ஒரு வெர்டிக்கல் லைன் போடணும். அப்போ வந்து பார்த்தீங்கன்னா 56 + 16 + 51. ஸோ அதுதான் இங்கே அவங்க கால்குலேட் பண்ணியிருக்காங்க, 16 + 51 ஃப்ரம் த சார்ட். அதே மாதிரி ஓவல் டக்டுக்கும் அதே அடுத்த பேஜில் இருக்கு, 16 × 53. இட்ஸ் எனஃப். நெக்ஸ்ட் நம்ம என்ன பண்ண போறோம் அப்படின்னா, இந்த ஈக்குவலண்ட் டயமீட்டர் அப்ரோச்சில் the ரவுண்டுக்கு 30, கிராஸ் செக்ஷனல் ஏரியா 4.91 அண்ட் வெலாசிட்டி இஸ் ஈக்குவல் டு 1528. ஹவு இட் இஸ் கால்குலேட்டட்? இதுதான் வந்து we have to use the frictional chart. ஸோ இது நம்ம கால்குலேட் பண்ணணும்னா we must use a frictional chart. So frictional chart is a very important in a equal friction method. I just open the frictional chart. இதான் வந்து frictional chart. இப்போ I will explain the frictional chart clearly. Here there are 4 lines are there. So one is a horizontal line, another one is a vertical line. So in a horizontal line, there is an along x-axis. I will tell this is x-axis. Along x-axis, air quantity is given in a CFM. So here I just adopted all the units in the pounds per inch. And the vertical, the frictional loss is given in inches of water per 100 feet only. And there are an incline line. So there is a one incline line. I just you just follow the arrow mark. This incline line that gives the duct diameter. There is a equivalent duct diameter. This line, the line which is having the less than 30 degree with respect to the vertical line is known as, this line gives the duct diameter. அவங்களே கொடுத்துருக்காங்க. அடுத்து ஹரிசாண்டலுக்கு இன்க்ளைண்டா ஒரு லைன் போதும்ல, அது எதை கொடுத்துருக்குன்னா வெலாசிட்டியை கொடுத்துருக்கு. இப்போ நம்ம என்ன சார் பண்ண போறோம் அப்படின்னா, ஸோ நமக்கு ப்ராப்ளத்தில் வந்து 2 கண்டிஷன் கொடுத்துருக்காங்க. ஸோ கண்டிஷன் வந்து பார்த்தீங்கன்னா 7500 CFM, அடுத்து 30 diameter. இந்த ரெண்டையும் பேஸ் பண்ணி என்ன பண்ண போறோம், I have to find out velocity as well as a friction. So air quantity பார்த்தீங்கன்னா 7500. So air quantity is 7500. So here 1000, 2000, 3000, 4000, 5000, 6000 and 7000. This is a 7500. I take a pen. So this is a 10,000, 9,000, 8,000. This is a 1000. Change the color so you can see. So from this point you draw the vertical line. So where it should be intersect? It should be intersect at 30. So here you can see the line.
Dr. Muthukumar sir.
Yes.
Sorry for interruption. Kindly conduct through English only. So
Sure.
various all expecting from you through English.
No problem, sir. No problem. Thank you, sir. Thank you. So here what I'm doing here, air flow rate is a 7500. From 7500 I have to draw the one vertical line. So up to which line? Here you can see the diameter. The diameter is a 30 degree. The diameter is a 30 degree. So it intersect at a 30 degree. So that's all. And then you just mark a point. Then from the point you draw the horizontal line. So the horizontal line may intersect one point here. So where you can measure. This is a 0.1. This is a 0.1. This is a 0.2. So I will assume it may be available in between 0.1 and 2. So frictional loss is equal to 0.15. What is the velocity? So this is the velocity. So velocity comes this line 1800 as well as 2000. So 1800 and 2000. So I make it as a average. There is a 1900. So this, using this chart only, we can find out a value. The velocity. Oh, sorry. I think it comes 1800. Okay, this is 30. Correct? Idan 30. Yeah. Okay, it comes between 1600 and 1800. You may see one more here also. I just open this. So this chart is a very important, sir. So using the chart only, the equal friction method is adopted. So 10,000, 9,000, 8,000. This is a 7,500. This the 30 mm. So here clearly given. So the velocity comes between 1,400 and 1,600. So it may taken as 1,500, but it is calculated exactly using a sizing calculator. I will tell how the sizing calculator may be used. So similarly, for a flattened oval, the values may be calculated for 1361 and 1362. So this is an equivalent diameter approach. So now using a equivalent diameter approach, so what we are getting, the frictional loss. The frictional loss is a constant. The frictional loss is a constant in an equivalent diameter approach. But in an equivalent cross-section area approach, what I am doing, the cross-section area is maintained as a constant for 3 types of cross-section. Circular, there is a 4.91 is maintained in the cross-section area, and other dimensions are calculated using the formula A cross B as well as A is equal to pi B squared into B into A minus B. So here airflow is 7,500, the cross-section area 4.91, the velocity mostly the same, but the frictional loss is the increasing. The frictional loss is increasing. So what's my observation based on an equivalent cross-sectional area approach as well as the equivalent the diameter approach. In an equivalent diameter approach, it is retain the same pressure drop because the frictional loss is a constant. This value is a constant, and but result in a higher cross section. The cross section area in a higher of a rectangular and oval duct compared to round. But equivalent area approach increases the pressure drop and duct run while keeping the cross section area the same. So which one is a more suitable? That is a design engineer is a decides. So you know your application. So your applications, so if you want to design without the pressure losses, I have to maintain the pressure drops to be 0. I think you have to maintain a equivalent diameter approach. But here material cost is very high because we have to use a higher material. But if you are using an equivalent area approach, the material is minimized, but the pressure drop is one major criteria. So you have to compromise. So the compromisation is the major thing of the design principle. Okay, now I just move to the major the concept that is duct sizing. The duct sizing, there are the 3 methods are popularly used in a duct sizing. The one is a equal friction method, another one is a constant velocity method, and third one is a static regain method. The equal friction method is a mostly adopted in most of the design engineers and most of the air conditioning engineer. So it is normally used in a residential and a commercial application. And constant velocity application, so this method, the constant velocity method is used in the palace and high class villas and the deluxe apartment. So in this method, we are not worrying about the cost. Here we are worrying about the comfort. So we need a high comfort. So velocity is minimized. So the noise is minimized. But other things are we are not worrying about. Only comfort. The material may be increased, whatever it is. We are not worrying. And the third one is the static regain method. which is normally used in an industrial application. That's called the higher velocity. Here the velocity is greater than 3000 to the 4000 FEM. The feet per minute is used. But in an equal friction method, normally we are using the velocity values around the 2500 method. Velocity reduction method is a very rough method. So normally this method is not used in anywhere. Okay, the first we will move to the equal friction method. The most widely used method to size ducting is the equal friction method. So equal friction design method sizes the duct for a constant friction rate. So both are same, which describes the average pressure drop per 100 feet of the duct in a system. I just saw the one graph, use a ASRE handbook. So the same. So where the friction rate is calculated for 100 feet of duct in a system. Then the same value of friction lot for length of the duct is used to size. Then we have to convert into our required length. It may be converted. And then frictional lot rate is chosen to result in an economical balance. For economical balance, for a duct cost as well as a energy cost. First you have to find out, and then we have to choose which one is better. So by considering a duct as well as energy cost, fan cost and other things. A higher friction loss result in a smaller ducts. It results in a higher operating fan cost. So higher friction loss may be avoided in an equal friction method because it results in the high energy cost. That is high operating the fan cost. This method is universally used for a supply duct, return duct and exhaust duct. All type of ducts are designed using this method. So here you can see the velocity as well as the friction value. So low velocity and medium velocity systems are used. The friction value is 0.08 to 0.158. This is for a equal friction method, and velocity ranges around 900 to 2500. So these things are normally used for a first two method, constant velocity method as well as a equal friction method. And high velocity duct system, normally it is used as static regain method. There is a static pressure regain. We are gaining a static pressure. That is a static regain method. The high velocity duct system for a 2500 to the 4000. I think this is the procedure is a given. I just moved to the one problem. So where we will discuss some of the things, and then we will move to the next problem. So advantages of equal friction. The method is a straightforward and simple. It automatically reduces the air velocities in the direction of airflow. We will discuss how, which in turn reduce the potential of airflow generated noise. It is the most appropriate method for a constant air volume method. Limitation. There is no equalization of a pressure drop in a duct branches. There is no equalization of pressure drop is a varying. So balancing damper must be installed. The balancing damper is a very important. It is not flexible. It is not flexible and adaptable to future layout changes. We can't change a layout for a future. Once designed, we have to follow the other things. And one more limitation is here the duct size. The maximum duct size is equal to 30 feet. So beyond the 30 feet, I think this method is not suitable. That's also one more limitation of equal friction method. This is a friction chart, and this is a friction chart of how the values are selected. So I just moved to the one problem. Here I have given one case study. We have one I have one air handling unit at the starting. From the air handling unit, I have to distribute the air at 6 different locations. I have listed as a 1, 2, 3, 4, 5, 6. So how much air is distributed for each location, which is calculated by us regarding the room size and other things. There is a load calculation is a totally different. We have already calculated. So based on the calculation, I have distributed 1000 cubic for one location 1. Similarly, for location 2, the same 1000. For a third, same 1000. 4, same 1000. And 5 and 6, it is distributed as a 500 and 500. Now the total is a 5000. So if you sum up please note down, if you sum up all the things, it should be equal to the input. The input is equal to output. That's called the system. So if you sum up all the things, it is equal to air handling unit total input. So okay, it is correct. And then I have why I'm using this kind of arrangement, because of the room. because of the room and other things. So I have to arrange the duct from A to B. So A is the outlet of the air handling unit, as well as the B is the way to the first room. So this is a B, A to B. In between A to B, my air quantity is 5000 CFM, and then B to C it becomes a 4000, because 1000 CFM is taken by 1, so it becomes a 4000 CFM. And then once again from C to D, the air quantity is equal to 3000 CFM. So and then in between D and E, the air quantity is 2000 CFM, and between E and F, the air quantity becomes 1000 CFM, and last it becomes a 500 CFM. Now this problem is going to solve, so using equal friction method, as well as equal friction method, as well as a friction chart. So I'm going to solve the problem. First you're using a friction chart, next I'm using a duct sizer software. Duct designing with equal friction method, X-ray charts and table, same problem. I draw the different colors. Red color indicates the duct, and 1, 2, 3, 4, 5, 6, and all the informations are given. So what is the duct type? For a equal friction method, duct should be a low velocity duct, or as well as the medium. So low velocity as well as a medium duct system may be used. What may be the velocity range? It should be 900 to 2500 feet per minute. Friction loss. What is the friction loss? From the table I have to take it as a 0.082 to 0.15. For actual practice I take a low. So if you take a low pressure loss, we discuss the reason. So low pressure loss, I think we will get the small pressure drop. That purpose only we are using a low friction losses are selected. And then application, this where I am using it. Application is a hobbies. So application is hobbies. The height of the duct is equal to 14 inch. The application is hobbies, and the height of the duct is equal to the 14 inches. So now I choose one important thing is the recommended maximum duct velocities from X-ray. Recommended the maximum duct velocity from X-ray. This is application. This is a controlling factor for noise generation for a main duct. This is a controlling factor for a duct friction for a main duct as well as a branch duct. So I am going to design only main duct. First I am going to design only the main duct. So what is the application? The private offices. The private offices. So the supply of air is equal to 2000. You please note down, I have to consider only third column. Third column is for a friction method. The second column is only for a constant velocity method. So this column is selected for a constant velocity method. There is a second method. So we will discuss. So for private offices, here given is 2000 CFM. There is the air velocity. The maximum air velocity allowed as per X-ray is 2000 feet per minute. So I have to check it. First I have to check it from X-ray table. So maximum velocity of a low velocity system is equal to 2000 feet per minute for a main supply duct from the X-ray table. First you have to check the velocity from the chart. So how it will be calculated for a first duct? So airflow is equal to 5000 CFM. Friction loss is equal to 0.008. So then what you have to do? The same thing. So from 5000, I have to draw vertical line. This is a 0.8. From 0.08, I have to draw horizontal line. Sorry, some line may. So okay. So I think exactly this point come here. So where you can check the velocity. The velocity is in between 1200 and 1400. So in between 1200 and 1400 and equivalent diameter. So equivalent diameter is taken as a higher value. Equivalent diameter is taken as the higher value of this chart. So the point comes below the 26 inch. So it may be taken as the 26 inch, the equivalent diameter. So here the calculated velocity is 1300. I have to calculate it approximately. So I just take it as the value between 1200 and 1400. So here the calculated velocity is 1300 CFM and it is less than the table value. So we can continue the problem within the limit. First you have to check the velocity for one branch. For our other value, that is a maximum. For other values, there is no need to check, because so your value comes 4000, 3000, 2000, 1000 and something. So your value comes the below this line only. So the velocity comes below 1300 only. There is no need to check the other branches. So first you have to check the velocity for the first branch. There is a AB. If the calculated velocity is greater than the table value, okay. So now here the selected value is less than, so we can continue the problem. But sometime, if the calculated values are greater than the table value, what can I do, sir? For example, if it is a greater than 2000 CFM, it is taken care of the friction loss. So you have to reduce the friction loss as 0.07, at 0.006 and 0.005. My aim is to reduce the friction loss. So if you reduce the friction loss, I think you may get the minimum velocity. There is a less than the table velocity. This is very, very important for a equal friction method. First you have to check a velocity, then mathematics. The remaining things are fully mathematics. It's a very, very simple. You just draw horizontal vertical line and then you have to select a value and you have to do some mathematics. But this is engineering. So checking of 1300 velocity is engineering. If it goes beyond, you have to reduce the friction loss. For other things, there is no need to check, but anyhow, you have to calculate the velocity of air. The velocity may be computed. So I have calculated the velocity may be the computed. Okay. Now the duct size, the Q is equal to 5000, F is equal to 0.08 weight of water column for 100 feet. From a friction chart, now only I have calculated the equivalent diameter is equal to 26. The height of the duct is given. Here the constraint, the height is the 14 is given. So for one side of the length is equal to 14, the other side of the length is calculated from this table. So this is a 14. So you see the 14. The equivalent diameter is a 26. Here you can see the 26 and 14 meter 14. Sorry, 44. So width of the first duct is equal to 44 cross 14 inches. There is a WH. So next you have to check aspect ratio. This is very, very important. Aspect ratio. So I have to check aspect ratio. That is a 3.14. Okay, it's okay. We can go for the next duct. For a next duct, Q is equal to 4000 and F maintained the equal friction method. That is a method. Equal friction method from 4000. This is a 4000. You try to draw the line. There is no need. I think 24. The equivalent diameter is equal to 24. So outer diameter is equal to 24 inches and then velocity is equal to 1200 to 1400. The height is equal to 14 inches. So width, how the width is calculated from the ASRE handbook fundamental. From the page 21.10, I taken the same page, the 14. You don't change the width, but the equivalent diameter, equivalent diameter calculated from the table is a 24. So 24, I think 44. Not a 44, 36, sorry. 36 into 36, you can see. From 14, draw vertical line. Then you have to draw things. Okay. So 24-inch diameter of the duct. So 36 into 14. Similarly, C2D. C2D, I think equivalent diameter. I think this is a 3000. I think equivalent diameter is a 22. The higher is a nearly is a the 22. So here 22 is a diameter of the duct. So size of the duct is equal to 30. 24. 24. 36. Sorry, 22. So you remember the correct value for a 22, for a 14, this is a 30. 30 cross 14, the aspect ratio should be within the 4. For higher value, you have to check it 3.14, then aspect ratio correspondingly reduces. And then a duct size DE. For a duct size DE, for a 2000, there is no need. This is a 2000. And then my equivalent diameter is a 20. I have to take a, sorry, closer. Closer is a, not a 20. This is a 2000. The closer is a 18. I take it as a, the diameter of the duct, equivalent diameter is a 18. And so the width of the duct is equal to the 14 degree. The width of the duct is equal to 14 degree, and equivalent diameter is a 20 inches. So 20 and 14, there is a 24. So 20. Sir, please read that for 20. 24. So 24 into the 14, this is the duct size. I made as a 20, but originally it is a 24. And then a duct size EF. The duct size EF. I just move to the problem. Then only you get a clear idea. The EF. For a EF, the volume rate is 1000. For EF, the volume is 1000 CFM. The F is equal to same. The diameter of the duct is equal to 14. The diameter of the duct is equal to 14. Here you have to draw. I have to take it as the higher. This is a higher 14. Equivalent diameter is 14. And here it 14. Circular diameter is equal to 14. But the given value for 14, there is no values are available. So at that time, what you have to do? So you have to go for the lesser value because of maintaining the best aspect ratio. So this is a very important in a equal friction method. So width of the duct W is not available for a 14 inch of height. So the height of the duct is reduced to next even number, that is a 12. H is equal to 12. Now width of the duct is selected is equal to the 14 inches. அது நம்ம இங்க பார்த்தோம்னா தெரியும். இந்த இருக்கு 14. So here you will get a square duct. 14 cross 12. So 14 cross 12 is obtained. And the last one, duct size F2G, Q is equal to 500 CFM and F is equal to 0.08 from chart. So diameter of the duct is equal to 500. This is a 500. Diameter of the duct. This is exactly it lies between 10 and 12. So it may be taken as 11. The diameter of the duct is equal to 11. For a even diameter of 11, no other values are available for a 12. Once again, you have to go for a 10. So 10 cross 10. So one side is a 10, another side is also 10. So square duct is selected. This is the duct size for my last one, F2G. So this is the method which is adopted. So using the equal friction method using a chart and table. And now there is one important thing is available, that is called duct sizer. I can't can anyone notice the value? If you notice the value, no problem. Otherwise, I will give. Sorry. Now, using this duct sizer software, we can download. We can find out all the things. But here it will get a exact value. So using our friction chart and table, we can get approximate value like Ilayaraja sang. But using a software, it is like a A.R. Rahman sang. We will get exactly like a keyboard. So sound comes from keyboard, tung tung tung. But this is a equal friction method. It is a flexible, so like a harmonium output. So here first you have to select the units. Normally I think most of the softwares are available in only pounds per inches. So the same unit is adapted, and then the condition. What is the condition? I have to take it as 75 degree Fahrenheit air at 50 degree of relative humidity at 1 atmosphere. The fluid density is equal to 0.0731. So this value is given. I think okay, from ASRE table, that the value of fluid density is given 0.075 the pounds per feet cube. Here the fluid density is equal to 0.0731. So if you are using equal friction method, so you have to apply 5000 CFM, and head loss is a constant 0.08. So you will get the velocity 1286.7, and the equivalent diameter is a 26.7 inch. That's not available. So one duct size is a given 14. So 14. So in my calculation for the first calculation, the equivalent diameter is, I think any one of you support me. What is the value? 44. 44 cross 14. But in a software, you will get a 14 cross 46. That's a issue of the calculator. That is the issue of the calculator. If you go with a chart, I think you may get an accurate result, and you may do some flexible. There is a flexibility is there. Here it is a given. What can I do? You can't do one thing. So 46 into 14. This is the first one. Okay. And then second, I may reduce 4,000. Second, I may reduce 4,000. So velocity is equal to 1219. It is a less than 2,000. And the duct size is a 38 into 14. But I have calculated 30 cross 36 into 14. There is a 2 inches error will come if you use a chart as well as a calculator. That's your wish. Normally, most of the people who are academic purpose, they are using only this calculator. For if you want to do any commercial application, for real-time application, the chart is the best. Chart is the best. It gives the correct value. And 4,000, it is 14 cross 38. And then 3,000, 30 cross 13. It's a correct 30. And 2,000, 2014 cross 22. For 2014 cross 22. But our answer is also 14 cross 22. I did a mistake. And the next one is 1,000. The next one is 1,000. For 1,000, here there is an issue. So if you come by any even number, there is if any comes odd number, you have to convert into the next even number. So 14 cross 14. So I have taken as the duct EF is equal to 14 cross 14. And the last one is 500. Last one is 500. For 500 CFM, so 14 cross 8. 14 cross 8 duct size 14 cross 8. But here I have to change as a 10. So if you make it as a 10, I think you will get a 10 cross 10. But the previous one, originally I used 12 here. Size is a 12. So I got a 12 cross 16. For 1,000, I got a 12 cross 16. So this is an answer which got from our design software. Then you may find out the branch duct diameter using this method. But CFM method, I have to choose a 14 cross 12 for a branch duct. For all branch ducts, the first 4 branch ducts have 1,000 CFM. So duct size is equal to 14. The duct size is 14 inches plus 12 inches because it has only 1,000 CFM. The last 2 branch ducts have 500 CFM. So 10 inches cross 10 inches. So the same values may be used. Otherwise, you may check with. You may check here. I think here also you will get the same. So this is the method which is adopted in equal friction method for determination of duct size and velocities. Mostly what we are doing here, we are finding a velocity and the equivalent diameter for what is called equal friction method. In constant velocity method, what we are finding, equivalent diameter and head loss. The friction loss is a calculator. That's all. So can I move to the next? Sir, can I move to the next procedure?
Okay, sir. Carry on.
Okay, Karen, thank you. So this is a constant velocity method. The same problem is converted into constant velocity method. Here, what are the principles we are going to adopt? The velocities through entire system is maintained as a constant. Velocity selected based on the second column in a recommended table of ASRE. I shown on table number 7. So velocity selected based on a second column in a recommended table of ASRE. And since velocity is a constant, Q is reducing. So because of continuity equation. So Q is equal to VA. The velocity is a constant, Q is reducing. So area will reduce and pressure drop will increase. There is a friction loss will increase. That's we will discuss. But sound level will be very low. This is very, very, very important advantage of constant velocity method. The sound level will be very low, but pressure drop will be very high. So because of less velocity and so comfort. Based on CFM, there is a air size. Each section same velocity. Circular duct diameter is a calculator from chart, and then rectangular size is calculated. Application is a palace, high class villas, and a deluxe apartment. So here I just show on a problem. So this is a very important, similar to the previous problem. One air handling unit, it may be distributed into 6 different locations, but here concept is a very important. Velocity should be very, very constant. So application is a high class villa. So velocity is a constant. How it will be calculated? 5,000 divided by 6. First you have to calculate 5,000 divided by 6. So in your calculator you will get a 833.33. Please note down, you get a 833.33. So the first, second, third and fourth, the 5 units have the velocity of 834 and the remaining is a 830. So if you sum up all the values, it should be equal to 5,000 CFM. This is very, very important. So this is a thing we have to adopt in a constant velocity method. In a equal friction method, so in a equal friction method, what we are doing, we have distributed. The velocity is varying, but here the velocity should be very, very constant as well as the low. So why the value becomes a very low? Once again, I move to the table. Once again, I move to the table. Here, apartment. So there is a high class villa apartment, the hotel bedroom. So this is where comfort is very important. So the second column, air velocity is equal to 1000 CFM. Air velocity, sorry, 1000 FEM. So the same, so 1000 FEM, that value should be less than. So your value should be less than the table value. Then only you may continue the problem. So otherwise, so you have to do something. So you have to do something. So here I think I have distributed all the values, and then CFMLA air quantity for a duct AB is equal to 5000. Now it is a subtracted 834, so it becomes a 4166, and then 332, and then 2498, 1664, and 830. And now we can calculate and we can enter the value. So first one, 5000 CFM. Here velocity becomes a constant. Then you have to check it air condition. Velocity becomes a constant 834. 834. What is the friction? So friction value is equal to 0.027. We have to check it if it is increases. Equivalent air 33.8. And then duct size. So I have to fix the duct size is equal to 14. 14. 14 means I think it is not suitable because it increases. If you am using a 14, what will happen? Aspect ratio 78 divided by 14. Aspect ratio is a 5.6. So it is not advisable. So the height of the duct should be increased. So if you use a 66 divided by 16, here aspect ratio once again 4.125. So the duct size is maintained as a 18. So the duct size is a 18. So 56 divided by 18 is equal to 3.11. So here very important is the aspect ratio. So aspect ratio. So rectangular size is equal to 56 cross 18. I have calculated. The second one, the flow rate is equal to 41666. Flow rate is equal to 4166. The velocity is the same and the equivalent diameter. So friction value is varying 0.03. It increases. So equivalent diameter is reduces. If area decreases, automatically pressure increases. So obviously 40 cross 46 cross 18. 46 cross 18. Once again, you have to check aspect ratio. Anything you have to do, aspect ratio is a very important. Otherwise, they won't accept 2.55. There is no need to check 2.55. The next one, 4166. Next one, 332. 332. So the value is gradually increasing. This is very important. Equivalent diameter is gradually decreasing. And 36 cross 18. 36 cross 18. And then DE. What is DE? DE 2498. For a DE 2498. For a 2498, the pressure value is a 0.041. And equivalent diameter 23.4. And rectangular size obviously 26 cross 18. 26 cross 18. Next, EF 1664. For 1064, the value is a 0.053 and the equivalent diameter is a 19.1 and the rectangular size 18 cross 18. This is square duct. The last one 830. The last one 830. The friction loss is equal to 0.081. There is a tremendous increase in pressure. So 13.5 and 18 cross 10. 18 cross 10. So otherwise you may change here. If you need 12 means you make it as a 12 also, whatever it is. But here you put this 18, it will come 9. So I made this 18 into 10. So that's all. So these are the friction. Now you can see. So this is a very important in a constant velocity method. The pressure drop. The pressure is a increases. The pressure is a increases, but velocity is a constant. So the comfort level. So the duct size automatically it is also increases. It is very the critical in a constant velocity method. This is I have calculated using a shortened short method. chart and table. So you may compare mostly the two values 50 cross into 18. Here you get a 58 into the 2 inches will come in mostly in chart method. Some error will come. So this is the concept behind the constant velocity method. So if you have any query about the two methods, you will ask, I will clarify. Then I will move to the last one, the static regain method. So that method is a very lengthy and a complicated method. We can't complete the problem within 20 minutes or 35 minutes. It consumes more time, but anyhow I will give the idea of the static regain method after clarifying your doubts. Sir, if you have any doubts, you may ask, sir. I'm ready to clarify, and then I will move to the next type, static regain type.
Doctor, you may do. Go ahead, please.
Okay. Thank you, sir. Thank you. This is a static regain method. The name itself gives the method. Here the meaning is a static pressure regain. We are regaining a static pressure. So what is the concept? Here you can see this method is commonly used for a high velocity system with long duct that is greater than 30 inches for industrial application, especially large system. So above 2 system is not applicable for 30, but as per design rule, we are not going for a 30 inches for a equal friction and a constant velocity. So we have cut off even 24 inches also. This method uses a conservation of momentum principle. In this method, the static pressure is maintained the same as before the terminal and branch. Here some static pressure is available. The same pressure is maintained here also. So that is called a static regain. So what I am doing, the pressure should be equal or the pressure should be greater than, not less than. இங்க இருக்கிற pressure எப்படி இருக்கணும், ஈக்குவலா இருக்கணும், இல்லைன்னா இது ஜாஸ்தியா இருக்கணும். இந்த pressure என்ன இருக்கக்கூடாது, கம்மியா இருக்கக்கூடாது. The pressure should not be low. This pressure should be very high than this, or at the time it may be equal. But in problem solving, so we are using the greater than or equal to. Mostly we are taking as a greater than. The static pressure should be calculated as greater than. So this is a procedure. The velocity in the main duct leaving the fan is selected first. The velocity in each successive runs are reduced such that the gain in static pressure due to the reduction in velocity. So when the velocity is reduced, it is a gain in static pressure. It equals the friction pressure drop in the next duct section. Thus the static pressure before each terminal or branch is maintained at a constant. If the section 1 is a outlet of the fan, then its dimensions are known from the flow rate and velocity. However, since both the dimensions and velocity at a section 2 are not known, the trial and error method has to be followed to solve the equation. Here it is a known to you because before there is no static pressure. This is the first one. So we can calculate a dimension to the other thing. But the second one, it may be calculated by a trial and error method. So I am saying it is a very lengthy process. So use a calculator, use a friction chart, but the value is assumed by you. The velocity is assumed by you. Then we have to check it the static pressure. How the static pressure is check it at using this equation. So the static pressure is equal to recovery factor into V1 divided by 4000 whole square plus V2 divided by 4000 whole square. What is a V1? The velocity at a previous duct section. V2 is equal to velocity at a current duct section. So if you want to calculate the BC, so you have to substitute a velocity at the previous. So that velocity should be very high. So this is a static pressure. The value compared the previous value, it should be greater than. What is the recovery factor? It is depends upon the shape of the fittings. Normally, this value is taken as a 0.9, the higher value. Higher value gives the higher static pressure. Lower value gives a lower static pressure. So I am taking higher value. That's a concept. That's all. Okay. So which gives a required dimensions of the section 2, and then using you have to find out a static pressure. The procedure is followed in the direction of the airflow. and the dimensions of the downstream of the ducts are obtained. As before, the pressure drop is obtained from the pressure drop in the long run, and fan is selected. This method yields a more balanced system. This is the best method and does not cause any unnecessary dampening. However, velocity reduces in the direction of the airflow. The duct size may increase the airflow. So the velocity at the exit of the longer duct runs may become too small for a proper air distribution to the conditioned space. So because of the sizing of the duct, it distributes properly to the required area. So this is the advantages of the static regain method. Now I just take this method for only two space, AB and BC. For a CD and DE, I think it took more time. Now the time is nearly 12:30, so I took the first two duct. This is a problem. Air handling unit 8000 CFM. It is distributed to 4 spaces. It is distributed to 4 spaces. That's 200, 200, and 200 CFM. CFM is a air quantity, and velocity. Here the velocity is not given. The velocity is assumed by for a industrial application. Once again, I move to the last table. The industrial application. The industrial application. This is not a constant velocity method. So this is also in one type of a friction method. So here you can see the 3000. The main duct, the 3000 speed is a 3000. So same value. So 2000 to 4000. So 3000 FEM is selected. This is the condition. High velocity duct system having a velocity of 2500 to 4000 FEM. So it is a 3000 FEM. So here you can see. So air quantity between A and B is 8000 and B and C is a 6000 and it is a 4000, 4000. Here the length is a very important. Then only we may calculate a static pressure. For up to the previous problem, we are not worrying about a length. So here we are using the length of the pipe is a very, very essential. Now I just move to the problem. It gives the better idea. AB and BC, and if time permits, we will calculate the CD also. We will calculate the CD also. Okay, so here you can see, I will take only 10 minutes. I will close the session. Same, first you have to clear. All the informations are clear. Then you have to choose the correct air conditioning. So what are the informations you are going to substitute here? What are the information we are going to substitute here? Flow rate and velocity. So flow rate is equal to 8000. The velocity is initially assumed as a 3000. The maximum velocity is assumed. This is very, very important. The maximum velocity is assumed, and the duct size is also assumed. So 8000, 3000, friction is equal to 0.511 in a water column of 100 feet. 0.511 water column of 100 feet. Then it is the length is 50. The friction is converted into for actual value. So it is multiplied with the 0.5. I get a 0.2555. And static pressure, there is no static pressure. The difference between the previous and the present is a static pressure. This is a starting first duct. So the previous is a no duct, so no static pressure. Equivalent ion 22.1 and 26 cross 26, sorry, 26 cross 16 selected. The next, this is a trial and error method. So what is the flow rate? 6000. 6000. Next I am substituting a velocity is equal to 2600. Here I am substituting a velocity is a 2600. I am reducing of the 400 CFM. So what is the value? I got here 0.355. You please note down 0.3355. and then 0.3355 is multiplied with the 0.5. So I got sorry, not a 0.5, 0.4. 0.335 is multiplied with the 0.4. I got the original value 0.134. Then static pressure. What is the static pressure? I think it should be calculated. I just saw the equation. If anyone, if you have a value, you may calculate. Otherwise, I have calculated 0.126. I have to take it as R is 0.9, V1 is 3000, V2 is 2600. So static pressure is equal to 0.16. So what is the value? Now this value is this value should be greater than this value. You please note down, this value should be greater than this value. But here, this value is lesser. So equivalent diameter is 23.8. So other thing is 30 cross 16. But this is not selected. So what is the reason? This is the very, very critical point. So this value is very, very, very low. So if it is very low, it is not acceptable. So next, what I am doing, the velocity is so here my aim is to increase. So I have to reduce the velocity. That's a concept. Static regain. Reduce the velocity and increase the friction. So 2400 I have to substitute. 2400. I substituted 2400. So if I substitute 2400, CFM is 6000. CFM is 6000, and my friction is 0.345. I have already used. Then 0.345 is multiplied with the 0.345 is multiplied with the 0.4, 0.138. Now static pressure. Static pressure should be calculated by the equation. So if anyone helps me, what is the value of static pressure? You have to check it. I got a 0.182. I got a 0.182. So if you have a calculator, you have to calculate, then you will get it. So 20.182. Now this value is greater than this value. It should be equal, but it's greater than, no problem. So greater than, so this branch is selected. Similarly, you have to conclude, you have to go for a CD, DE, and so on. So this is the method of a static regain method. So we are regaining static pressure. So the name is called a static regain method. How it is regained? By reducing the velocity of gear. If a velocity is reduced, automatically the pressure is increases. So I got the static pressure increases is obtained. So all the things are maybe calculated using this design tool, duct sizer, Macquarie. You may download this software, and then ASA handbook also available in the net. You can download. So in the particular handbook, I think you will get all the information. This is I have downloaded ASRE handbook of fundamentals. I just saw the tabular column and other things. This particular book gives more information about that duct design. This is here you can see the friction chart. 0.075, the 0.075 pounds per meter cube. So frictions are, this chart is used. So in our duct design software also the same value. Once again, 0.075. Now we go to the software, 0.0731. It's very closer to the table value. And then I saw the this is a table 21.10. You see the dimensions, the equivalent rectangular duct dimension, similarly equivalent flat oval duct dimensions. Similarly, there are a lot of informations are available in the handbook. Based on the handbook only, I just prepared all the presentations, and some material I have downloaded from the internet, and I have referred some YouTube lectures also. So I just collected more information, and I delivered a little bit about duct design method. I'm not sure can I transfer the enough information to you? I am waiting for your feedback and the questions. So thank you. Now the time is at 12:40. Sorry, I took the 10 minutes. Sir, if you have any questions, you may ask.
Dr. Balasubramani,
Yes, sir.
this is true. Excellent. It was very well. But I request
sir.
you to kindly, one more time, you have contact once lockdown vacated for Israel Madurai members.
Sure, sir. Sure, sir. I will contact. Local member only.
Local languages. Local languages.
That is a local member, local language.
Not only for local language, local members, but local languages. Because
yes,
it should be thoroughly understood. Okay.
Because many
this is my humble request that you.
Sir, no humble. I am ready to take one more time. So one more time, no issue.
Sir, your request is noted, sir. We will definitely, after the lockdown, we will definitely do a session in our history office, sir.
Sure, sir.
Thank you, Raju. Thank you, Raju.
Sir, is there any questions from audience?
Yeah, any other questions from the audience? You can ask. It's open now.
Dear Balasubramani, congratulations, you did well. I am K. Chukalingam.
Sir. Thank you, sir. Thank you, sir.
Actually,
you, sir.
as a layman, I am having one small doubt. Is that you have calculated some duct size, and in software you find out some size. There was a difference between 2 inches or 3 inches in size. In that, if the difference comes, which one will be preferable, whether the software size or the calculated size?
Sir, that is a role of a design engineer, sir. Sir, if you consider the software size, it increases the material, sir. Normally, software gives a 2 inches higher. So, if you use a friction sort value, I think it consumes the minimum material. So, material, the cost, everything is the less, sir. So the minimum area may be considered, sir.
Okay, thank you.
That's thank you, sir.
Thank you.
Sir, any other questions, sir?
Chat box. No questions, sir.
The reason is language.
Sure, sir. But initially, our Punjabல இருந்து ரெண்டு பேரு ஒரே ரெக்வெஸ்ட் பண்ணிட்டாங்க.
Yes.
Sir,
and also Mr. Kristen from Mumbai, frequently he wrote the messages also.
Oh, sure, sir.
That way I disturbed you in between.
Sure.
So, any other questions, sir? Sir, then let me put up my questions there. Right, sir, you have in the second method that you have explained in equal velocity method.
Constant velocity method, yes, sir.
Sorry, constant velocity method. You have assumed the value of 834 in the calculation, sir. Actually.
No, sir. What I am doing, sir. Actually, எத்தனை location இருக்கோ, based on the location, the 5,000 is divided by 6. In my calculator, it gives 833. Here, I can't distribute evenly. If I can't distribute evenly for a 6 location because of the value.
Sir, after the slide, you have shown the calculation in the table now, sir. Like, yes, here actually it would have been preferred if you have used the 1,000 as the velocity here, sir.
Sir, if I'm using 1,000 means, sir, velocity.
Sir, the table in the hash rate tells that it should be 1,000 FPM now, sir, actually. So in the table, preferably the calculation should have been with 1,000, sir. That's it. Otherwise, it was perfect.
We may, sir, why I'm not using 1,000 in a table, the maximum is 1,000, sir. So we must prepare less than the 1,000, sir. That is ASRE thumb rule, sir.
Okay.
ASRE thumb rule is that is a very important, sir. So we must use less than 1,000, sir. So not a less than 1,000, less than the table value. That is a recommended maximum duct velocity for both the methods, sir.
Agreed, sir. Okay. Thank you, sir.
Thank you, sir. Thank you.
Sir, any other questions from the audience?
Thank you, Dr. Balasubramani, as well as ISRE Madurai chapter for organizing a wonderful session. Thanks a lot.
Thank you, sir. Thank you, sir. Thank you.
Thank you for all the member support and all the senior members and the students who have participated, and also people from the other chapters also. We might have missed out a few people in addressing them. Sorry if we have missed your names. Now, sir, Dr. Balasa, you want to have any final words?
Sir, first I thank Rajiv sir. Rajiv sir has guided me a lot too for preparation of this material. Initially, we interacted. He told, sir, you please concentrate on an equal friction method. Then you may do whatever it is, sir. But that method is adopted. Then you give a quizzes doing in between a lecture. It will motivate. And I also thank the Sridhar sir also. The Sridhar sir also guided me for preparing the better presentation material. Yesterday I discussed with the Sridhar sir. So this is a way of presentation. So he gave some ideas because most of the people are technicians. So you have to change your presentation in by giving some case studies and other things. Then only the sessions may be made live. So I thank sincerely to Rajiv Krishna sir and Sridhar sir for making a good presentation. And I also thank all the ISRE members once again. And I thank my HOD, Dr. K. Chokalingam sir, for permitting me to give this lecture in ISRE. I thank one and all. I thank you, sir.
Thank you for your time. In a very short notice, you have done an excellent presentation, sir. Like you have gone in depth into each and every topic, and then you have made the viewers, hungry for the knowledge. And also, this is very clearly showing that they are asking for a same session again. Once in Madurai chapter, it says the content of the topic that you have chosen, sir. Thank you for giving a very in-depth and thought-provoking program for us. Thank you, sir. Thank you. Over to Krishna Karna.
Honorable President and other office bearers, I affirm it as an honor to be proposing the vote of thanks on this occasion. First of all, I would like to thank Dr. V. Balasubramani, the speaker for the day, for his efforts on reaching us today and sharing his knowledge among us. I'm very sure that your webinar was much enjoyed by the participants as well. Next, I'd like to thank the President of ISRE Madurai Chapter, Dr. K. Sridhar sir, President-elect Mr. Savaridas Franklin sir, Secretary Mr. K. Kaja Mohideen sir, Treasurer Mr. N. Balachandran sir, Program Chair Mr. Rajiv Krishna sir, for being a constant pillar of support for this event to be successful. Thanks to Dr. K. Chokalingam sir, HOD of the Mechanical Engineering Department, Tyagaraja College of Engineering, Dr. G. Kumara Guruparan, the Students Chair of ISRE Madurai Chapter, Mr. K. Tirunavakarasu, past President and past RD, Dr. Krishnaveni, Professor, GCE Tirunelveli, Dr. C. Muthusamy, HOD, SIT, Dr. Uday Kumar, National Vice Chair, Student Activities, Krishnan Vishwanathan, IEC Chair, Guru Pratap Singh, past President, ISRE Jalandhar Subchapter, for making your presence here. Last but not the least, I'd like to thank each and every one of you in the audience for being fantastic listeners and for making sure the event was a great success. We, our organizers, are indebted to you. Thank you once again.
Bala sir, super இருந்ததுங்க சார்.
தேங்க்யூ உதயகுமார், தேங்க்யூ.
நல்லா நைஸா பிரசன்ட் பண்ணீங்க சார். as usual எனக்கு அப்படியே நீங்க டிசைன் எடுத்தது எனக்கு ஞாபகம் வந்துருச்சு. ஆஃப்டர் ஒரு 20 years பேக்.
நீங்க தான் கரெக்டான ஆடியன்ஸ்.
என்ன சார்?
இல்ல நீங்க தான் கரெக்டான ஆடியன்ஸ். மத்தவங்க எல்லாம் வேற. சார் வணக்கம்.